Lesson 13-2 is over isosceles triangles. So it says to define an isosceles triangle. And on this figure right down here, it says on the triangle below, classify and appropriately label each side and angle using these terms right here. So, for sake of time, I'm just going to click over to the teacher's version and provide you with all that information because me to write it takes too much time. So, by definition, an isosceles triangle is a triangle with at least two congruent sides. And this is the part that most people miss is that word at least. Most people say an isosceles triangle is a triangle that has two congruent sides. But by this definition right here, a triangle that has all three sides that are the same length is also isosceles. Now, you probably have already learned in previous courses that a triangle with all three sides is called equilateral. And if you haven't, then, or I think you learned it earlier in this course, but an equilateral triangle is also an isosceles triangle. So, just a little detail that could mess you up on a test question if you're not real careful and know the definition precisely. So, at least two congruent sides. Now, when we have um, just the two sides that are the same length, we call those, each one of those, a leg. And then there's that third side that's not the same as all the others. That side is called the base. Now, a lot of people get confused because they think that the base is what the triangle is sitting on. But I can draw you an isosceles triangle right here. Okay, these two legs right here, obviously the two that are the same length. And this is still a leg, this is still a leg, and this here is the base. It has nothing whatsoever to do. We could take this triangle right here and turn it upside down, and the base would be on the top. This is the base. And the reason it's called the base is because it's the odd man out. So the legs are the two that are the same length. That third one is the base. And across from the base, that angle that's across from the base, or we say opposite the base, that angle is called the vertex angle. Now, in a equilateral triangle, all of this still holds true. The only difference is it does not matter which one of these you call the base because all three legs are the same length. So if you call those two the legs, then that one's going to be the base. If you call these two the legs, then that one's going to be the base. And if you call these two legs, then this one down here would be the base. But still, across from the base would be the vertex angle. Okay, so across from the base would be the vertex angle. The reason it doesn't matter on this one is because all three of those angles measure 60 degrees, so it doesn't matter. These two angles down here, the ones that are adjacent or made by a leg and a base, a leg and a base, those are called base angles. What I usually do is identify the vertex angle first, and then the other two are just called base angles. Or you could say it's the two angles that are formed in part by the base. So those are base angles. Okay, so that is the vocabulary. Now, it says draw and cut out an isosceles triangle. So I did. I didn't draw, well, I did draw, I will draw one because it's not a hard thing to do, but I actually cut one out, is what I did. Just because I wanted it to be super neat and um, really clear. I'm having trouble focusing. There it is. And I will show you how it's super easy to draw one. All you need in order to draw an isosceles triangle is a ruler. and of course something to write with. And it absolutely positively does not matter how long you choose to draw the first side. But let's say I draw that first side 6 centimeters long. Okay, so if I've drawn that first side 6 centimeters long, it doesn't matter whether you connect another leg to this one or down here to this one. It doesn't matter. Just be sure that that second leg that you draw is also 6 centimeters long. So which end you attach it to or how big the angle is, that absolutely does not matter. But this one and this one are the two legs. And then to create the base, all you have to do is connect the two endpoints of the legs. So we've got leg, leg, base, and this here is the vertex angle, and these two down here, these are your base angles. And that's how you could draw it, and then of course you can cut it out. Now let's click back over here real quickly to see what they wanted us to do. Draw and cut out an isosceles triangle. So I've done that. Fold your triangle so that the two legs coincide. Now, if you're not sure what coincide means, that might be something you could look up. But what they want you to do, what they want us to do is they want us to just fold this triangle so that this leg and this leg are right on top of each other. So they just want to fold it in half. And once you get it folded in half, if you cut it out really well, okay, I've got it folded in half. All right, so one side is folded onto the other. Okay, let's see what they want us to do next. List the conjectures about the relationships that you observe in the angles observe in the angles of your isosceles triangle. Okay, so first of all, if you remember when we did lines of symmetry, remember this line of symmetry right here, what it did was take this one object and created two objects. One that could be considered the pre-image and the other one that could be considered the image because they're the same size. And my camera just froze. There it is. It came up. So, since these are two identical images, that means that because this angle right here folds over and matches this angle, then we can mark this angle right here and this angle right here as congruent. Okay. Now I'm going to draw a line where that fold is. I'm going to draw a line where that fold is. We'll try to get it perfect. Oh man, it's not perfect, but y'all have to deal with my goof. Okay, so we know that these two sides right here are congruent because that's from the isosceles triangle. We just because these two are images, mirror images of each other, we know that these two angles right here are congruent. And for the same reason that these two angles were congruent, we would know that these two angles right here are congruent. Okay, and that's going to make our triangles congruent, couldn't it? By angle, angle, side. Yeah, angle, angle, side. So that means that these two little angles up here are also congruent to each other. I need to put 3 marks. And that means that this one right here is congruent to itself. And then that means that these two right here are congruent. So the fact that we've got two images that are exactly the same, they're just mirror images of each other, all of the corresponding parts are congruent. All right. Let's go back and see what they wanted us to do. List the conjectures about the relationship you observe in the angles. What appears to be true at the base angles? The conjecture is that they are congruent. All right. So now it says, let's prove the isosceles triangle theorem, and they want us to start by the proof by drawing in an angle, the bisector of the vertex angle. They want me to bisect this angle right here. So this is the vertex angle. How do I know? These are the two congruent legs. The two legs form the vertex angle. Let me see if I can make this a little bit bigger. And then they want us to write a proof. Okay, so there is a way that you can construct the angle bisector. I don't know, I can't remember if you've done constructions yet, but we're just going to draw it in and we're going to mark the picture right here. We're going to mark the picture as congruent. So we drew it in. Everybody knows that you can bisect the angle. It's not a matter of can it be bisected. Of course it is. If it exists, then we can cut it into two equal pieces. So we've just done that. And now we are doing a proof. The proof of the isosceles triangle theorem begins by drawing the bisector on the, and it says write a paragraph proof. So the first thing we would want to do when we write this paragraph proof is I would probably say triangle ABC is isosceles with, and we would want to tell them AB congruent to BC. Tell them which two of the legs. Then I would say that we would need to name this point down here. Are you okay naming it D? Then I would say that BD bisects angle ABC. And that was given. Okay, these two were both given pieces of information. So I would probably start by saying given ABC is an isosceles triangle, and I wouldn't have to put that right there, and BD bisects angle ABC. I would put a 1 and a 2. So we could say, so angle 1 is congruent to angle 2 by the angle bisector definition. Or you could end the sentence right here and just say angle 1, angle 2. Angle 1 is congruent to angle 2 by the angle bisector definition. Okay, so we've got a pair of sides. We've stated that the pair of sides is congruent. We have stated that a pair of angles is congruent. And then we can say that side BD is congruent to side BD. Why do we know that that's congruent to itself? It's one of those properties, by the symmetric property. Or is it reflexive? It's reflexive. I'm sorry. It's the reflexive property. Reflexive says that anything is congruent to itself by the reflexive property. Okay, so now we've said this. Have we said that, do we have enough information? Yes, to say that the two triangles are congruent. Triangle ABD is now congruent to triangle CBD by side angle side And now that we've got those two triangles congruent, we can say that angle A is congruent to angle C. I'm just stopping.